In this question, it is given that for any vector A, we need to find the value of this whole thing. Okay, so let's assume this part as 1 and this as 2 and this as 3. So from 1, we can write it as minus of I cap cross A vector cross I cap. Now just use the cross product. I mean, use the vector triple product. So multiply first with the far element, that is I dot I into A minus I dot A into I cap. Now it becomes multiply the negative sign, you'll get I dot A into I minus I dot I is 1. We have discussed the property of dot product. It becomes simply A. So similarly, from second equation, just replace the unit vector I with unit vector J. So it becomes J cap dot A vector into J cap minus A. Similarly, third can be written as K cap dot A vector into K cap minus A. So if we add 1, 2, 3, because this we actually want, right? So it becomes I dot A vector into I plus J dot A into J plus K dot A into K minus 3A vector. So here, let us assume A vector as A1 I cap plus A2 J cap plus A3 K cap. So if we multiply A vector with I cap, what we actually get? We get A1 and I cap remain as it is. Similarly, here we'll get A2, J cap remain as it is, and A3, K cap minus 3A. Again, what is this actually? It's nothing but the A vector minus 3A vector. It becomes minus 2A vector. So this is the required answer to this question. In this question, it is given that if A, B, C are non-coplanar unit vectors, which means the magnitude of all the three vectors is 1, such that this condition holds true, then the angle between A and B is. So let's use this condition. Use the vector triple product formula, you'll get it as A dot C into B minus A dot B into C, which is nothing but 1 by root 2 B vector plus 1 by root 2 C vector. We actually want the angle between A and B. So let's compare this C vector with this. From here we will get it as A dot B is nothing but minus 1 by root 2. Use the formula of dot product, that is magnitude of A, magnitude of B cos theta, that is minus 1 by root 2. As all the three vectors are unit vectors, magnitude of A and magnitude of B will be 1. So cos theta will be cos 3 pi by 4. Therefore, theta is 3 pi by 4. So this is the angle between the vector A and B. In this question, it's given as A vector and B vector are given. And if C is a vector such that A dot C is magnitude of C vector and C minus A, its magnitude is 2 root 2, and the angle between A cross B and C is given as 30 degrees, and we need to find the value of this. So from here we can write it as, using the dot product formula, we need to find magnitude of A cross B into magnitude of C sine 30 because the angle between A cross B and C is 30 degrees. Final answer, we need to find out this. But before that, do we know the magnitude of C vector? No, right? So let us first find out that. So let's use this condition, okay? From here we can write it as, let's do squaring on both sides. Magnitude of C square plus magnitude of A square minus 2 C dot A is equal to 2 root 2 square is nothing but 8. So C dot A we can write it as magnitude of C. So from here magnitude of C square becomes magnitude of A square is under root 2 square 4 plus 1 plus 4. It becomes under root 9, that is 3. 3 square is nothing but 9. Minus 2 magnitude of C is equal to 8. Magnitude of C square minus 2 times of magnitude C plus 1 is equal to 0. Just simplify this. You'll get it as magnitude of C minus 1 whole square is equal to 0. From here, we'll get magnitude of C as 1. Okay. So just simplify over here. A cross B, magnitude of C is 1, sine 30 is half. So we need to find the value of A cross B. So it becomes I, J, K. A is 2, 1, minus 2. B coordinates are 1, 1, 0. Just take the determinant of this. It becomes I cap 0 to I cap. And for J, it becomes minus 2 J cap. For K, it becomes plus K cap. And when you divide this by 2, you'll get it as I cap minus J plus K cap by 2. What will be its magnitude? Because in answer, we need to find the magnitude, right? So it becomes under root 1 plus 1 plus 1 by 4, which is nothing but 9 by under root 9 by 4, which is 3 by 2. So 3 by 2 is the required answer to this question.